Hello students, good morning to everyone. In our last video we discussed about the basic fundamental things. Basic things are fundamental things relating to circle. What is circle? What is fixed point? What is chord? What is radius? What is diameter? What is an arc? What is segment? What is major segment, minor segment, semicircle, major arc, minor arc? All things we discussed in our last two videos, but today we will discuss about the theorem relating to circle. So whenever you do theorem, the very important point of the theorem is we should know the congruency conditions which we discussed earlier. If you don't see the video, please watch that video again and again. There are 5 conditions of congruency which is very important for our future life or geometry portion. Now look at the first theorem. The straight line drawn from the center of a circle to bisect a chord which is not a diameter is perpendicular to the chord. Now this is a circle. A straight line drawn from the center. Suppose this is a center O. A straight line drawn from the center of a circle to bisect a chord. So there is a chord. Here is a chord. This chord, name of the chord is AB. Bisect the chord means suppose this midpoint is M and this is O. This is the center of the circle. Join M O. Now see the question again. A straight line drawn from the center of a circle. A straight line drawn from the center of the circle. The center O. A straight line OM drawn from the center of the circle bisect a chord, because M is the midpoint of the chord, so AM is equal to BM. So we join the line O to M because M is the midpoint of the bisect means midpoint. Bisect a chord which is not a diameter, which refers to what? Which is not a diameter, which refers to the chord. Bisect a chord which, that is the complex sentence, that is a clause, relative clause, which is not a diameter is perpendicular to the chord. Which is not a diameter, this is not a diameter, this is a chord, which is perpendicular to the chord means OM is perpendicular to AB. We have to prove. Means given point, what is given point? A straight line, a circle with center O. AM is a chord means AM is equal to BM. AM is equal to BM because bisect the chord. Bisect a chord means the chord divides two equal parts. AM is equal to BM. Now to prove, OM is perpendicular to AB. This is the proof. OM is perpendicular to AB. Now construction. Join OA and OB. join OA and OP, this much. Then we will go to the proof, PROOF, proof. Now look here, here there are two triangles, AOM triangle, OMB triangle. I always tell that you should always remember the congruency conditions when we compare two triangles to each other. Now here is a triangle OAM, OBM. We have to prove this angle is equal to this angle, that is equal to 90 degree. So AM is perpendicular to AB. Now in a triangle AOM and BOM, in triangle AOM and BOM, number 1 point, OA is equal to OB. Look, OA is equal to OB. Why? Because the radius of the circle, the one circle, same radius of the circle. Number 2, AM is equal to BM. This is given, AM is equal to BM. Number 3, OM is equal to OM. OM is equal to OM, common side. So we know that three sides of one triangle are equal to the three sides of the other triangles. Then two triangles are said to be in congruence. So triangle AOM congruence to the triangle BOM, that is S. Very easy. Then all other angles are equal. So AMO, angle AMO is equal to angle BMO. AMO is equal to BMO, but the sum of two angles are 180 degree, means measurement of the angle AMO plus measurement of the angle BMO is equal to 180 degree, because linear pair, because two angles are supplementary to each other. So sum of two angles are 180 degree, but they are equal. So each angle is 90 degree. So measurement of the angle AMO is equal to measurement of the angle BMO, that is equal to 90 degree. Here this is 90 degree, means OM is perpendicular to AB. Proved. OM is perpendicular to AB. Very easy theorem. A straight line joining drawn from the center to the midpoint of a chord is perpendicular to the chord if the chord is other than the diameter. First we wrote in our given point a circle with center O, AB is a chord, O is the center, M is the midpoint of AB, that's why AM is equal to BM. Then to prove OM is perpendicular to AB, construction join AO and BO. Then we take two triangles, triangle AOM and triangle BOM. OA is equal to OB, same radius of the same circle. Then AM is equal to BM, that is equal to given, and OM is equal to OM common side. So the three sides of one triangle are equal to the three sides of the other triangle. Then two triangles are said to be congruent by S. Then other three angles are equal. So AMO is equal to BMO, but AMO plus BMO is equal to 180 degree because they are a linear pair or supplementary to each other. So each angle AMO is equal to angle BMO is equal to 90 degree. That means OM is perpendicular to AB. Then this is the theorem 1. Then theorem 2, just reverse of this theorem. A line, second theorem, a straight line by a line from the center perpendicular to the chord bisect the chord. This is the second theorem. A line drawn from the center which is perpendicular to the chord bisect the chord. If this is perpendicular, we have to prove AM is equal to BM in the next theorem. It is very easy. You can prove by taking two congruent triangles. Now take a screenshot. A straight line drawn from the center of a circle perpendicular to the chord bisect the chord. This much. The straight line drawn from the center of a circle perpendicular to the chord bisect the chord. Now you can prove by your own language. Here is a circle, here is a center, here is a chord, that is AB is a chord. A line drawn from the center of the circle which is perpendicular to chord. This is suppose AM is perpendicular to AB. OM is perpendicular to AB. We have to prove AM is equal to BM. Given a circle with center O, OM is perpendicular to AB. This much is given. Then to prove AM is equal to BM. Then construction. Join OA and OB. Prove. Join OA and OB. Then prove. Take two triangles. In triangle AOM and triangle BOM. OA is equal to OB. Radius of the circle. Radius of the circle. OM is equal to OM, that is common, and AMO is equal to BMO, that is equal to 90 degree. Given three things are given. because this is perpendicular to OM is perpendicular to AB, so OA is equal to OB, which is the radius of the radius of the circle. OM is equal to OM common, AMO is equal to BMO, that is equal to 90 degree given. So this is right angle, this is hypotenuse, this is side. So two triangles are congruent to each other. Triangle AOM congruent to the triangle BOM, RHS, right angle, hypotenuse and side. So AM is equal to BM, proved. Very easy to prove. This is to prove the two theorems are over. Then how many theorems are in your book? We will cover all theorems, examples, exercises. The circle chapter is very interesting and easiest chapter, easiest topic. Try to understand and try to work out, practice again and again. For today this much. Thanks. Goodbye.